there's been a lot of talk recently in the industry over the last few years about asset visibility. But asset visibility is just a start, right? Like it's not the same thing as management, and we'll kind of show you how we differentiate ourselves in this field. So what I'm going to do is I'm going to walk you through how a typical deployment would go and how we would start to bring assets into the asset management platform of the ASM, so that we can do additional things like configuration and vulnerability management, and provide reporting against cybersecurity standards like the NIST CSF. And so we come here, and what we've done is we've deployed some different sensors. So we have the sensor right here focuses on passive discovery. So this is going to take in network traffic and it's going to parse it for information. There are other sensors. There's one called the ASA, and what that's going to do is that's going to have active assets defined for it. So, but one of the simplest ways to just get started with us is to just plug in our passive sensor and let it start collecting network information, right? And many of the customers we deal with, they're going from no knowledge, right? Especially like when you're in that like separate owner infrastructure from operator infrastructure, like you really have no idea what's going on. I've worked with several organizations that are set up that way from both sides. And really one of the biggest things is as an owner is you're putting a lot of trust in the operator without a whole lot of verification capabilities, right? Like, we've done the accounting, we have standard accounting rules, we know how all that works, we know how how to trust but verify in that world. Where we're kind of lacking that same understanding is here in the OT security world. And so what this does is this allows you to kind of have that visibility. And so what we're going to do is we're just going to plug a sensor in, and it's going to start collecting information about devices. And as you can see here, it's going to dump them into the discovered state at first. It'll resolve a host name if it can. It'll collect IP addresses and MAC addresses. It'll start to guess what vendor this is. So here we can see some, here's some VMs that we can see. Texas Instrument. This is looks like I'll know it looks like a BACnet device over there in a second. But a Netgear switch. Schweitzer Engineering. This is really popular as a electrical relay in the utility business. Here's some Siemens gear. There's Huawei. So that's very interesting that there's a Huawei NIC. And that has significant, infrastructure, critical infrastructure implications there. Supermicro, Asus Tech, you can just see some more Siemens, different assets. There's Apple, it's probably my laptop. But as you go through, you can see stuff. And the other thing we do is we'll start to build characteristics around these assets. As I said, this is BACnet most likely. So, and I know that because I know how it works. It says Tritium. Tritium is a BACnet building management system. Here you can see here we see that this device is talking. It's a Modbus slave, so it's talking Modbus. So even though it's a VM, it is very much involved. It's probably a virtual controller of some kind. As we scroll down, we'll see some different ones. Again, another Modbus slave as a VM machine, some more Modbus. It's probably something running PCAPs, would be my guess. Some different things there. If we go down, and then you can see down here, here's some more BACnet stuff, BACnet, and there you see we're calling out the protocol itself. And so as we go through, you see these different things. And so what this is intended to do is this is an onboarding zone. So many of the stuff that we're doing is we're focused on bringing in assets, and so we're going to focus here on bringing in assets, and we're going to highlight them. And so you get a choice of what you want to do. And so we're going to come here and we're going to go, this asset is discovered. Many of the cybersecurity tools stop here, right? They bring everything on board. They don't call it discovered. They don't call it, they don't really give you any workflow here. So what you're going to do is you're going to go in and you're going to say what's discovered versus not. And so you get to do workflow management here. And so we're going to manage assets. And so here you have ignore. Here you have accept, and accept is going to mean it's a net new asset. And if I choose accept, it'll allow me to bring it into the fold and assign like a name to it and a collection profile to it, which tells the system how to talk to that device. It allows you to activate it or leave it unactivated, which means alerts and all those things kind of pour through. The other kind of key differentiator you get here is merge. Many assets in this world, especially on the passive side, really struggle with assets that are what are called multi-homed, which means they exist on multiple networks. Gateway devices serve this role, routers often serve this role, firewall serve this role, and you're able to merge them and tell the system that it's one physical device. Um, so as we go through, we get these different options. Ignore is really nice though, because what you can do is like oftentimes vendors show up and they have what some people call what are called transient assets. And so that means an asset that doesn't live on the network, isn't really part of the managed infrastructure, doesn't serve an operational role on a day-to-day basis, but they come through and maybe they have different various uses. So oftentimes it might be a vendor. And so you can just say, you know, Jeremy from ID was here, you know, C change ticket 1, 2, 3, 4, 5, 6, right? And then you hit submit, and all that happens to that device is it goes into ignored mode, which means it doesn't trigger alerts or stuff. But none of the profile things get picked up or dumped. So if you did have an event, you'd be able to go back and still see and understand this data. Many others in the space require you to just delete that data if you don't want to manage it or see it in your network. And so otherwise it'll still trigger alerts and events and that kind of stuff. They don't have a good way to do that. So that's what we often do. So now we're going to move into, once an asset is administered, what does that allow you to do? So here you can see we're administering assets. So this is all the assets that are administered in my demo system. There's several different types of devices. Here we have some Rockwell controllers. If we look down here, there's some Siemens S7 devices. You know, here's some Schneider building management stuff. Here's some electric utility stuff. And as well as like Windows devices and Linux devices. And so we're just going to focus on some different things. So here we're going to go to, you know, this is very commonly found in the oil and gas industry, a 1756 Rockwell controller, and we're going to see what kind of data we're collecting on this asset. So here you can see we actually know this is a multi-card chassis. And so, you know, it's several different cards within the 1756 main management module, and then there's a couple communication adapters, but there's also a logic controller. They all have their own, you know, their own firmware version. They have their own serial number, and then you can even see for the logic controller if someone has left the key switch, you know, remote versus local or program versus run. Often a key issue. And that there, so you have that kind of information. And again, all of this was pulled back passive. This is a passively collected profile. You're not going to get much more information out of a passive device. But if we move into something a little more complex, like a FortiSwitch, here we're going to go in and we're going to look at what's here. You know, there's many more properties on this device. This is an active collector, so what we're doing is we're logging into a device actively. We're using a native protocol to speak to this device, and out of that native protocol, we're able to get a lot more information. So here we're using SSH to log into a FortiSwitch, you know, a common layer 3 switch, and here you're seeing different information about it. Some of this is, you know, the stuff you would want to know from a cybersecurity and configuration management standpoint, like DNS, you know, different kinds of settings. And then here, if we go to software installed, you can see we have the FortiOS is called out. So, and this is the, you know, the firmware version. It's very important when we're talking about vulnerability management. Patches aren't really applied to these devices, so there are no patches. Ports and services, we're actually getting from an internal read on the device. A lot of people talk about Nmap, you know, well, a lot of people talk about active and the dangers of active in an OT environment. What they're really talking about is they're talking about uncontrolled, untargeted, broad-based scanning, like you would see with something like an Nmap scan. We have Nmap capabilities and you can target it at specific assets, but where we can, we like to find the internal, right? Because the internal might actually be a more authoritative source. There's a whole lot of issues around like UDP filter, especially with UDP ports and filtering of firewalls and stuff that can really get, you know, kind of mess up the results of an Nmap scan. So getting an internal read from the device is often quite useful, and sometimes often more authoritative. And so here you can see all these services are running. It's nice to know that Telnet's running, but HTTP is, so that gives me something that I'd probably want to go look at and understand if I really need that on or if I can turn that off. The other thing is we're going to pull back a user account. There's only one user on here, and you can see what that is. And one of the other unique things we do is, since we're talking to the device and we're talking to it in its native protocols and using native commands, we can often do things that you would do as an engineer logged into that device. And that includes things like collect the running configuration off the device and the whole configuration. So what that allows us to do is back up the configuration of many of the devices that we see, right? Like, we're not a replacement for a Windows or a Linux backup system, but for many, like many of your switches and PLCs and stuff, these simple files are often what all you really need to recover a device. And so you can store them on the ASM. This is really critical, especially in the OT world, as we think about what happened with Colonial and they had ransomware running around. One of the kind of unspoken secrets in the OT space is many of your PLC backups and your switch backups, they exist on your engineers' laptops. Um, and so if those laptops get impacted by ransomware, you no longer have access to those. And so having another system that does this on a consistent and ongoing basis, and stores them in a centralized manner like this, like the ASM solution, can often provide you yet another area to recover from, in case your primary areas get stuck, right? Um, so that's a huge advantage, especially in today's world of malware. If we go into something even more complex, so now we're going to go look at a Windows asset, and we're going to go look at collected data off of a Windows asset. Again, 95 properties this time, a whole lot more. What is the audit policy? What are the password policies? Are the guest accounts enabled? Is the default admin account enabled? All the things that you'd want, and kind of correspond to those CIS benchmarks that come out of the Center for Internet Security. A lot of those same kind of settings. Here we can see software installed. What I want to point out here is this is an agent-based collector for Windows. What that allows us to do is it allows us to do things like define custom software installs. So here we're picking up a portable copy of WinSCP, a portable copy of PuTTY, and we're able to see that these are being dropped on the user's desktop, which is often an area that's invisible to most other collectors of this data. Here you can see patches that are installed, ports and services. These are the running ports and services. And again, with the agent installed, we can collect the child calling process under service host. A lot of malware likes to abuse service host because everything in Windows abuses service host. So they'll hide behind it, and being able to collect that child calling process is very, very useful in forensics and detection, right? And trying to catch something as quickly as possible. Firewall rules, this is the local firewall rules on the Windows box. Here you can see all the different user accounts. You can see we're picking up the domain group, as well as local users and local groups. Again, we can back up where we're not a replacement for Windows, but if there are critical files that you would like backed up or like to have some sort of hashing done against them on a regular basis, like a config.xml file for an HMI, we'll grab those as well. And then you can see the device interfaces, right? You can spend $10 billion on a network monitoring system if a engineer who wants to work from home is getting told no by IT, or a vendor who comes on site and knows that they're going to be missing and halfway across the globe for the next month, but knows that there's going to be call-in assignment work and that kind of stuff. All it takes them is like 5 minutes to go enable a new interface and hook it up to like a cable modem that's not managed by, or a Wi-Fi hotspot, and totally circumvent that $1 billion investment you've made in all your other cybersecurity tools. So being able to collect this type of information and detect changes here is really, really critical.